Hello. We are going to talk about sampling today. And specifically, we're going to talk about stratified random samples, cluster and multi-stage samples, and systematic random sampling. And then we're going to talk about some bias, and we're going to go back and classify our sampling methods as good or bad based upon um, our conversations and talking about bias as well. So, jumping right in, stratified random sampling. So, stratas are groups of individuals in a population who share characteristics thought to be associated with the variables being measured. And then a stratified random sample is when you select your sample by basically dividing the population into strata and then looking within each strata, coming up with a simple random sample, or in other words, an SRS of a certain amount of individuals from each strata, and then combining all of those basically SRSs into one big overall sample. And so you're only going to you're only going to stratify when you have a specific reason to. So for example, you feel as though maybe gender has some kind of a role or plays some kind of a role in whatever you're trying to study. So then you might stratify by gender and divide your population into males versus females, and then, select a group of randomly 50 males, 50 females, and then combine them together. And you do this so that you make sure that you have equal representation from both males and females because, like I said in the beginning, you feel as though their opinions may differ in some way. Okay, so let's look at an example. So a university has 2,000 male and 500 female faculty members. The Equal Opportunity Employment Officer wants to poll the opinions of a random sample of faculty members, and in order to give adequate attention to the female faculty, he decides that he should use a stratified random sample. And so he wants 200 males and 200 females. So he has alphabetized lists of the female and the male faculty members. So we're going to talk about how we would use a table of random digits to come up with this sample of 400 people, specifically 200 males and 200 females. Because we're specifying the gender of these people, this is what we would call a stratified random sample. So here's what we would do. We would basically take the population and divide them into males versus females. And if we start with the males first, we're going to number the men from 0001 to 2000 with unique 4-digit numbers. And then we're going to use the table of random digits to select digits 4 at a time. And I will do that now until we have 200 4-digit numbers between 001 to 2000. And we're going to throw out these repeat numbers. So, for example, my first number would be 1,387. So that would be my first male. My next number, I know you can barely see this, sorry. So my first, right there. My next 4-digit number would be 3815. Now that's not within this range, so I kind of ignore that number. I crossed out. 9895, cross that out. 0529, that's my next male. So 0908, that would be my next male after that. 7359, I would cross that off. 2751, cross that off. 8687, cross it off. 1369, I would include that. 5761, cross it off. So now how many do I have? I have 1, 2, 3, 4. I need one more. So 5458, cross it off. 0815. So assuming that we don't have any repeats, I don't think we do. So our first 5 males in the sample would be number 1387, and then we had 0529, and then we have 0908, and then we have 1369, sorry. 1369, and then finally 0815. So those would be the first 5 males that we would pick in our sample of 200. So now I'm going to basically do the same thing with females, but I'm numbering the females. I only have 500 in the population. So each female is only getting a 3-digit number from 001 to 500. And then I'm going through the table, selecting digits 3 at a time. Now, you have to be careful. You don't want to go back and use any of the digits that you've already used, because then they wouldn't be unique. So I'm going to start picking 3-digit numbers where I kind of like left off. And let me erase this here. Okay, so my last one ended with this 5 here. So my first 3-digit number is 072. So I'll write these as I go to make my life a little easier. So 072 would be my first female. 710 would be thrown out. 256. So 256. 027. So 027. 558 would get thrown out. 923 would get thrown out. 306. We're up to 1, 2, 3, 4 people, right? And then 341. So those would be my first 5 females that would be included in my sample. And so this is a stratified random sample. Okay. Let's talk about what's called a cluster sample. When I have a really large population, and it would be really hard for me to select a simple random sample, but I don't necessarily feel as though I need to stratify, I can basically group people by geographic region. So I would put them into what we call clusters, and I would group people like that are near each other or easy to reach in some sort of way as a group. And then what I would do is I would randomly select a couple clusters, and then I would include every member in the cluster to be as a part of my sample. So cluster sampling works best when basically the clusters are representative of the population. So people are all mixed up heterogeneously. So again, this is when my population is really large and I don't have the time or the money or the resources or whatever to do something else like an SRS. So let's look at an example. If you want to determine whether students at your school think that teachers are sufficiently available to students outside of the classroom, and then you have the resources to contact about 200 students. So my population is all the students at the school, and my parameter of interest would be the percent of students who think that teachers are sufficiently available to students outside of the classroom. So describe a sample design. And I give you, for example, will you use a stratified random sample with males and females as strata? So I don't really think that, gender is going to play a role in determining or in swaying people's opinion or impacting people's opinion about whether or not teachers are available to students. And maybe I'm wrong, but this is just what I think. So I also don't have a lot of time or resources to do an SRS. So what I'm going to do is a cluster sample. So I could group students into homerooms. So in other words, I'm grouping them out of like just making my life easier. So they're called a cluster. So I know that there's about 25 students in each homeroom, and I want 200 students. They told me in the beginning, we want to contact about 200 students. So if I reach out to 8 homerooms, and assuming again, there's about 25 students in each homeroom, I'd have about 200 students. So I now think of each homeroom as an individual, and I would select a simple random sample of homerooms. So let's say there's 40 homerooms in the whole school or something like that. I would, if there really were 40 homerooms, I would label each homeroom from 0, 1 to 40. And I would use my table of random digits, dividing up the digits 2 at a time until I get 8 unique 2-digit numbers between 0, 1, and 40. And then I would have those 8 homerooms that I selected be my SRS of 8 homerooms. Once I get those 8 homerooms, I'm going to select every single student or ask every single student in each of the homerooms to be included in the sample. So that's a cluster sample. So the people were still selected randomly, but they weren't really selected individually randomly. They were selected because they were in the random homerooms that I picked. An important distinction that I want to make before I go on any further about cluster sampling versus stratified random sampling versus a simple random sample. If you remember, as a part of the definition of a simple random sample is that in a simple random sample, every individual has equal chance of being chosen, and also every subset of size whatever has equal chance of being chosen. That's in a simple random sample. Well, let me give you this, or let's look at this example in a stratified random sample. So let's say, let me insert a new slide here for a quick second. Let's say I wanted a population, let's say my population is 2,000 men and 500 women, right? And let's say I wanted to select a sample where I had 200 men and 50 women. Each person would have a 1/10 chance of being selected, right? Because I'm selecting 200 men out of 2,000 and 50 men out of 500, right? I'm sorry, 50 women out of 500. So each person has the same chance of being selected. But this is a stratified random sample. I'm guaranteeing, so it's stratified random sample because I'm guaranteeing that I have 200 men and 50 women. So in other words, if I think of every, like, I have a total sample size, so my N is 250 people. So if I think about a simple random sample, or in other words, like an SRS, each person, each individual has to have equal chance of being selected. And in this case, that's true. That's true, right? But the second part of the definition is that each subset of size n has equal chance of being selected as well. In this case that I just described, that's not true. And here's why. So if I'm guaranteeing that I have 200 men and 50 women in the sample, there are possible subsets from the population that don't match this criteria. So for example, one possible subset from the population of 250 people could include, let's say, like 100 men and 150 women. So that's one possible subset. And I don't know who these men and women are, but if I were to come up with every single possible subset of 250 people from the population, it would include one that has 100 men and 150 women. And that's impossible. So it would be impossible for me to get this subset when I select my sample this way, in which I have 200 men and 50 women. So that second part of the definition here of an SRS is not met. And I bring this up to kind of show you why this part of the definition is so important when we have a simple random sample, and when that is kind of like violated when we look at something like a stratified random sample, or even in a cluster sample. Let me go on to look back at this example that we just looked at, this cluster sample. In this case, because I'm only selecting homerooms, if I think of the population, let's say I have like, I don't know, let's say I have like 2,000 students in the school, and I'm selecting a sample of 200, not every possible combination of 200 students is going to be possible to come up, because I'm only selecting people according to homeroom. All right, so just a quick clarification point. All right, so sometimes we just talked about cluster sampling, but sometimes even cluster sampling might be a little unrealistic. So we have what's called multi-stage sampling, and multi-stage sampling is more of kind of like a general term. It can look a lot of different ways. It's basically whenever you do sampling in multiple stages. So it's not really like a set firm definition, but it's essentially some kind of cluster sampling. And notice I say you could select a sample by dividing up the population into clusters and then randomly choosing a couple clusters. And then within those clusters, you could then cluster again, randomly choose select clusters, or you could do like an SRS within the clusters. Let's just talk through an example. So a quick example of a multi-stage sample is, let's say that the governor of Pennsylvania wants to know how high school students feel about a certain initiative, and he wants to survey students at 10 high schools. So the state of Pennsylvania is really big. There's lots and lots of high schools. So what they could do is they could divide the state into counties. Those are the clusters. So we're going to cluster by county. And then they could randomly select 5 counties. Then within each of those 5 counties, they could randomly select 2 high schools. So let's say they chose our county, Montgomery County, that we live in, as one of the first, in the first step here, right? So when they first divide the state into counties, Montgomery County is one of the 5 that they randomly select. What they would do is then in Montgomery County, let's pretend we have, I don't know, 100 high schools in Montgomery County. So then he could, or they could randomly look at those 100 high schools and do an SRS and randomly pick 2 of those 100 high schools. And then we would have 2 high schools in 5 counties. So that's 10 total high schools that they would look at. But even further, he could select 5 counties, select 2 high schools within the 5 counties, and let's say he only wants to pick, let's say he only wants to talk to 10 kids within each high school. So he could select 5 counties, 2 high schools, and then do an SRS to pick 10 kids in each high school. So then he would have 100 total kids, because he would have 10 kids from 10 high schools, so 100 total kids. So again, a multi-stage sample is just when you have like multiple stages of sampling that you do. And the reason that you do this is because your population is so big. You don't have the time, the money, the energy, the resources to do a full SRS or even a full cluster sample. Okay. And then our final method that we're going to talk about is called systematic random sampling. And systematic random sampling is typically used when your population is kind of unknown, when I don't really have like a population size. So I'll explain it first, but basically a lot of times this is used with like exit polling for like elections and things like that. You know how they make projections or predictions about who's going to be the winner in a certain state or in a certain county or whatever. They do this from exit polling, and this is how it works. So your sample is still selected randomly, but they randomly select one of the first K individuals and then choosing every Kth individual thereafter. So in other words, maybe I pick the 7th person who comes out of a polling location and then every 7th person after them. So this has its limitations, obviously, because maybe, for example, people are coming in groups and families or something like that. But at the same time, we only use systematic random sampling when we really don't have another way to sample. So this is not really as commonly used, especially for our purposes in AP statistics. But let's go through an example. So the final stage in a multi-stage sample must choose 5 of the 500 addresses in a neighborhood. You have a list of 500 addresses in geographical order. So in order to choose a systematic sample, here's what you would do. You would choose one of the first 100 addresses on the list at random. So you would label them 00 to 99, and then use a pair of random digits from the table of random digits. So look, let's do that first. So here's my random digits table. My first random digit is 69. So my first address that I would pick is whatever address, whatever the 69th address is. So the sample is going to consist of address number 69, and then 169, 269, 369, and 469. So 1, 2, 3, 4, 5 houses out of the 500, or 5 addresses, I should say, out of the 500. Okay, so that's a systematic random sample. All right, let's talk about bias. Under coverage, we have different types of bias that we're going to talk about. Under coverage occurs when some members of the population are less likely to be chosen or cannot be chosen in a sample. So let's go back to the problem that we just looked at, the looking for addresses. If I want to know, like income or something like that, who would be excluded? If I'm looking at the people who live at these addresses, I would definitely be excluding people who are homeless, or people who don't have their address listed, or maybe people who are like have lived in the neighborhood forever and are older and are retired, something like that, because their income probably would be lower than the people who are newer to the neighborhood, right? So under coverage occurs when people are less likely to be chosen or cannot be selected. Non-response occurs when the person who is selected to be in the sample can't be contacted or refuses to participate. So they just basically say, no, I'm not interested. Or maybe you have a phone number and they just keep on not answering the phone number. Or maybe you send them a survey and they refuse to fill out the survey. Response bias is when there's a systematic pattern of inaccurate answers to a survey question. Here's the best way I can describe that. If I, as a teacher, were to ask my students about like drug and alcohol use in class, if I were to just say, hey guys, you know, in class tomorrow, hey guys, raise your hand if you've ever used drugs or alcohol. Are people going to really answer me honestly? they're probably systematically way less likely to raise their hand and answer me and say yes than they would be if, number one, if I did like an anonymous survey, or number two, if let's say the teacher weren't in the room, if it were just a bunch of students in the room and they were like, hey, has anyone ever used drugs and alcohol? So it's when there's a people systematically feel like they have to answer a question in a certain way. Or it could be the same result if I said like, hey, how many people studied for this test? Maybe people are more likely to say yes, that they have studied for the test. The other thing that's not listed here is the way a question is worded. And this is the type of bias as well. So if I can ask a question in a certain way that leads to a response bias. So for example, even if I do an anonymous survey, I could write in the anonymous survey something like, oh, drugs, using alcohol and drugs can make people 10 times more likely to drop out of college and not have jobs and things like that. Have you ever used drugs? Even if it's a totally anonymous survey, I'm kind of swaying your response by the wording of my question, the information that I presented before I asked you this question. So a common misconception, and we have talked about this, but some students misuse the term voluntary response. So voluntary response is a sampling method in which people volunteer their responses. So in other words, remember like American Idol, who votes for American Idol? The people who choose to. When we think about people not wanting to participate in a survey, we call that non-response. That's a type of bias. So if you've been contacted to participate in a survey or whatever it is, and you choose not to respond, that's a type of bias. That's not the sampling method itself. All right, so based upon what type of bias these sampling methods introduce, we're going to categorize these as good or bad. And remember, this is like systematically. How are they introducing bias? So we've talked about convenience samples and voluntary response samples as ones that kind of systematically introduce bias. So we're going to categorize, I just checked them, but I'm going to actually X them. We're going to categorize these as like bad methods. Bad sampling methods. It doesn't mean that they're never used. It doesn't mean that they're like evil and that all data that comes from them is horrible. It just means that they kind of systematically introduce bias. These other ones all use randomization, and so we categorize all of these as good methods because, yeah, we talked about you could just be unlucky and get kind of a bad sample, but we're not systematically getting that bad sample. And that is it for today. Thank you so much for watching.